Hello students, today I am going to give you a brief introduction about stacks. It is a kind of a data structure. Data structure means whatever data we want to add that would be added in a certain format, and even when we are fetching the data from the data structure, it would be fetched in a certain pattern or a certain format. The contents that I am going to cover today is the push operation, pop operation, peep operation, and applications of stack. First of all, going towards the introduction of the stack. Stack is an example of linear data structure. It has a pointer called top, which will be pointing at the elements which are at the topmost of the stack. So whatever elements are in the top of the stack, there the pointer would be pointing. Secondly, the elements are added and deleted from one end only, that is the top end. So we cannot add or delete the data through other end. Next, initially the value of top will be -1. That means whenever the stack is empty, the value of top will be equal to -1. In some books and some references, the top is also initialized to 0. And below figure, you can see the example of stack that I have portrayed. These are the indexes of stack. This stack is of size is equals to 5. And the stack is entirely empty. That's why the top's value is equals to -1. Next comes the insertion of data into stack. The insertion of data is also known as push into stack. Let us begin with the first example shown in the first figure. Here the size of stack is equals to 3 and the stack is empty initially. That's why top is pointing at -1. Suppose if we want to push any data, suppose say we want to insert 40 into the stack, then first of all we need to check that whether the stack is having space or not. That means the stack is full or not. If the stack is full, then we cannot enter any kind of new data into it. So if the stack is full, then that condition is known as overflow. So we need to check the condition to be the stack as overflow or not. So in our case, let us check through the condition top is equals to size -1. Feed the value of top and size into this equation. So top is equals to here -1 and the size is equals to 3. So -1 is equals to 3 minus 1. So -1 is equals to 2. So the condition is not holding to be true and it is becoming false. That means my stack is not overflow and this condition is not true, so it will not go inside this block and it will go toward the second step of the algorithm. The second step of the algorithm, it is shown that we have to increment the top pointer by 1. So in our case, the top is currently pointing at -1, so it will be incremented to 1 and it will go at the location or index called 0. After moving the top pointer, we will be adding the data or we will be inserting the data where the top is pointing currently. So S of top is equals to V. Now V is the variable that is holding our data. So in our case 40 is being copied into V and this 40 is actually stored inside the stack where my top is pointing. So top is pointing at 0. So this statement would be S of 0 is equals to 40 and 40 would be inserted at 0th index. Next, if I want to insert 58, again we have to check whether the stack is full or not. So for that we have to find out this condition to be true or not. So in this case top is equals to 0. So 0 is equals to 3 minus 1. So 0 is equals to 2, which is not holding to be true. So it will not go inside this block and it will go for the second step. Now the second step is telling that increment the value of top by 1. So top is pointing at 0, so it will be incremented to 1. It has been incremented. Now we have to add the data that is stored in V variable wherever the top is pointing currently. So top is pointing currently at first location, so we will be adding the 58 data at first location into the stack. Again I am calling insert 102. So check for the overflow condition. If it is not true and is yes, in our case it is not true, so it will be incrementing the top pointer by 1. So which will take my top pointer to second index and then it will copy the data or insert the data at second index of the stack. Now You can see all the empty space has been filled up by the data, and there is no empty space that has been left in the stack. So after this current situation, if we are again calling the push operation, then check for this condition first. So what will be the condition? Top, which is currently pointing at 2. So 2 is equals to size, which is 3. So 2 equals 3 minus 1. That will be 2 equals to 2. So this condition is becoming true, and it will display the stack to be overflow, and it will exit the push algorithm because we cannot push anymore as there is no space inside stack. So I hope the insertion or the push operation into stack is clear. Going towards the next operation, that is delete operation. The delete operation into stack is also known as pop operation of stack. Pop operation is always deleting at the end, at the top, the pop operation will be always deleting the values or the data where the top is currently pointing. So whenever we are calling pop operation, the data at top would be deleted. So let us see the example in figure 1. It is having three elements into the stack of size 3. So my top is pointing at second index, and if I am calling the pop operation, it has to delete 102 because my top is pointing at 102. So whenever we are calling pop operation, the data would be deleted where the top is pointing. But before deletion, we need to check one thing, that whether my stack is underflow or not. Now what is underflow condition? If my stack is empty, then I cannot delete anything by calling pop operation because my stack is not having any kind of data. So this condition is known as underflow. So before deletion or calling the pop operation, we have to check for this condition, that whether the stack is underflow or not. And we are knowing that whenever the stack is empty, the top will be always equals to minus 1. So we are having this condition over here, that if top is equals to minus 1, then the stack is underflow and we will be exiting the pop algorithm. But in our case, the value of top is not equals to minus 1, but the value of top is equals to 2. So this condition is not holding true, and it will not go and it will not execute this block inside this condition, and it will go towards the second step. In second step, it will be fetching the data where the top is pointing. So top is pointing at second index, so it will be fetching 102 into a local variable called v. So now v is having the data 102. So we can use this data anywhere further in the program wherever we need it. Now that the data has been fetched into the local variable, then after we have to decrement the top by 1. So here the top is pointing at second index, so it will be decremented by 1. So currently the top would be pointing at first index. So here you can see the top has moved from second to first index. So now the top has moved. So the stack would be starting from 0th location and it will be ending at first location in the second figure. And 102 is out of the scope of this top, so that will not be considered as a part of the stack. And in this way, 102 is deleted from the stack and it is stored currently in V, where we can use this V anywhere in our program where we want to use it. Again, if we are calling the pop operation, first we have to check for underflow. So top of over here is of course not equals to minus 1 because the value of top here is 1. So it is not underflow. It will fetch this value, that is 58, pointed by top currently into a local variable called v, and after that it is going to be decrementing the top by 1. So here currently top is at 1, so by decrementing it will go at 0th index. Again, if I am calling the pop operation, it will check for the underflow condition. Here the underflow condition is again not satisfied, so it will decrement the value of top and it will be going one more step down. So now the top will go at minus 1 and this 40 would be deleted. So now the top is equals to minus 1. So again, if I am calling the pop operation, then what will happen? This condition will become true and it will display that the stack is underflow and it will exit the pop algorithm as we cannot pop the data further. So I hope the deletion operation is very much clear to all of you. Going towards the next operation of stack, that is known as peep operation. Now peep operation is used when the user is passing the index from the top of the stack and he wants to fetch the data at that particular index. But for that purpose, we need to check that whatever index passed by the user is valid or not. And secondly, whatever data the user is trying to seek should be there whenever the stack is not underflow. So if the stack is underflow, that means there would be no data. So we cannot do the peep operation. So we have to check for the two conditions. The first is stack is underflow or not, and the second is the stack is valid or not. So we can fulfill these two conditions by this equation, that is top minus I plus 1 is less than is equals to 0. This condition checks for both this condition of underflow and valid index. Let us check over here. If we are inserting peep of 5. Now peep of 5, that means fifth index the user is trying to look at. In our case, fifth index is not there inside the stack. That means the index is invalid. So let us feed the values into this condition. So I've written this condition over here. Feed the value. The top value is 2. The value of I is equals to 5 and 1. So 2 minus 5 plus 1 give us minus 2. So here this minus 2 is less than 0. That's why the valid is index and the index is invalid, and this statement would be displayed, that is index is invalid or the stack is underflow, and it would be ending the peep operation. Then after, if this particular condition is not true, that means it is false, then it will go at the second step of the algorithm where it would be returning the data from the stack, whatever data has been asked by the user. But make a note over here that the index passed by user is from the top to bottom, and the index that we are having in the stack are from bottom to top. So whatever index that has been passed by the user has to be converted into the format of the stack, that is bottom to top. So here in our case, for example, if the user wants to uh, see the data at second location from the top, then that means second location from the top, that means this would be the first location and this would be the second location from the top. Then feed the value over here. Top is equals to 2, so 2. User wants to see the second index, so 2. So 2 minus 2 would be 0, plus 1 would be 1. So S of 1. So S of 1 is 58. So actually user wanted to see the data at the second index from the top, which is the first index from the bottom of the stack. And the data is 58. So 58 is returned to the user. And this way we can see into the stack and we can peep into stack and fetch the data that we want at the particular index. I hope the concept of peep operation is clear over here. Some applications of stack in real world is, first is undo mechanism that we do in our desktops or laptops or any of the devices. What does undo mechanism do is, whatever we have done at last, by calling the undo mechanism, that would be called from the back. That means whatever we have done at last, it would be fetched first. That's why stack is known as LIFO, that is last in first out behavior. The second example or application of stack is pressing the back button in web browser, that will be fetching the last visited web page. So here also you can see whatever we have done at last, that will be entered into the stack, and when we are calling it back, when we are calling the stack back, it will be giving us whatever we have done last. The next application is infix, prefix and postfix notation. Also we can do recursion of functions using stack. Thank you everyone. I hope you have understood well whatever I have taught today. Happy learning.